Okay, so good day, class. Our topic for today is about neural networks, no? And we are going to discuss the concept about the neural networks. So, a neural network is a system that learns how to make prediction by the following steps, no? Like taking the input data first, no? And making a prediction, comparing the prediction to the desired output, and adjusting its internal state to predict correctly the next time. Okay? So, amo na siya class ang mga very basic steps, no? Of how the neural networks predict. Okay? So, vectors, layers, and linear regression are some of the building blocks of neural network. So the data is stored as vector. So when we say vectors class, um, it is like data, no? A matrix of 0 and 1. Okay? So and with the Python, you will store these vectors in arrays. So each layer transform the data that comes from the previous layer. So we will know later on, no, kung ano ni siya ang layer is all about. So you can think of each layer as a feature engineering step because each layer extracts some representation of the data came previously. So whatever the kumbaga whatever the data that comes from the input, so it will be interpreted or um, it will go through a certain layer in which there is a mathematical function that will calculate the input, no? And then it will somehow show an output. So, ang amo na concept class, we will learn that one step by step. Okay? So, one cool thing about neural network layer is that the same computation can extract information from any kind of data. And this means that it doesn't matter if you are using image data or text data. So whatever it is, no, kung image data siya or text data, so it doesn't matter because neural network pwede siya gamiton class sa image or sa text data man. Okay? So the purpose to extract meaningful information and train the deep learning model is the same for both scenarios. So let's say for example, may ara kitang simple architecture of this neural network with two hidden layers. Okay, so we call these layers or hidden layers. So this particular thing is input data. So say for example, this is your image, no? Okay. And then you have this first layer, then second layer, and then after that, it can predict that this image is, dancing, na? So whatever it is in this layer, in the first layer and the second layer, amo na siya class may mga formula ina siya diri. Okay? That's why ma-predict niya nga naga-dance or ang image pang-interpret niya, the person or the image here, it is kumbaga pang-interpret niya this is dancing, na? Okay, so yes, this is a neural network with two layers. So each layer transforms the data that came from previous layer by applying some mathematical operation. So as I've said, each of this layer has a formula or mathematical function nga parang isolve no ang input data kag maka-come up siya of course sa output. So the process to train neural network. Class, I've searched for several resources and or yes, no, to do this um, video, but some of the resources are really, very hard to comprehend, no? So I choose this one, no? But at least it is easier for us to understand because there is a step by step, no? Well, we are not expecting na maging sagad yung kita tayo, no? And we just have to learn the concept, no? And maybe later on, if you really want to learn, then you can improve or you can study using several resources online, no? Okay, may mga libro man and there are sample codes. So, it's up to your class, no? But basically, this is a basic concept, huh? So, training a neural network is similar to the process of trial and error. Okay? So, liwat kita, no? There is, later on, babalaan yung class kung may error, paano ang mga method, no? Okay? So, imagine you're playing dart for the first time. Okay? So, in your first row, you try to hit the central point of the dartboard. So, kung testing ka kuno class or naga-learn ikaw pa lang sang dart, you usually try to hit, no? Kumbaga, gina-project mo nimo in such a way nga maigo mo gid, no? So usually the first shot is just to get the sense of how the height and speed of your hand affect the result. So if you see the dart is higher than the central point, then you adjust your hand to throw it a little lower and so on. So kung nagkuha ikaw da ka dart pin class, so pag haboy mo, for the first time, ginatansya mo palang na class kung anong pwersang ibutang mo sa kamot mo, no? At the same time, the how low or high nga maigo mo gid siya, no? Nga mag-insakto ang trajectory mo, no? So that means to say, ang somehow in your mind, you are calculating the force you apply. And of course, kina-consider mo ang distance. So, kung ano siya kalapit, ano siya kalayo. Kag ang trajectory, kaya usually patimbuok or depende sa persa mo. May persahon mo. So, kaya niya somehow ang daw medyo straight, no? So, pero kung patimbuok, so, ano pa siya, medyo curvy siya. Kag umadagdag sa dart. Okay? So, as you try class, okay, nantaw na ito ng steps. Okay? So, throw the dart at the dartboard. So, that is your first step. Observe where the dart landed. Kasi, syempre, makita mo dira ang pagland niya, no? And, dira mo observe if, no, there is a tendency, no, kung halimbawa, adjust your hand position to land the dart closer to the center. So, basically, ang imo nga hand position, tapos kung ano ang i-apply mga force, dira naga vary, no? Kung baga mo ang imo input variable. Okay? So, may ara na class nga probably in P6, no, there is a way of solving that one, like paano mo ko ang gid ang trajectory, no? Passive force applied by variable na sina and then ang distance, no? So whatever it is, no? You repeat steps 1 to 3 until you get bullseye. So that means to say, medyo nag-adjust ikaw, no? So amo na siya class ang concept sang neural network, no? Kung baga ang hambal ta gani daw ano niya ang human brain, it is because through experience nag-adjust siya. Okay? So amo na siya ang concept sa neural network. So let's say for example, in practical application, kung may image ka dira agay na identify class, like for example this one image nga naga-dance. So basically ang imo dira nga layer, okay, may formula ina siya dira, no? and layer 1 and layer 2 nimo. So, mabalaan niya kung ano ang pag gina-interpret niya, no? In terms of pattern, no? Kag, whatever the elements or the parameters na ginagamit. So, basically, as it goes along, no? Mabalaan niya class nga nagadance kid man ina, no? Kung makaagi na siya sa first, second layer, and may gina-apply kita dira nga process, no? Like, forward and back propagation later on. Okay? So, step to hit the center of the dartboard. Okay? So, notice that you keep assessing the error by observing where the dart landed, no? You go until you finally hit the center of the dartboard. With neural network, the process is very similar. You start with some random weights, and bias vectors, make a prediction, compare it with desired output, and adjust the vectors to predict more accurately next time. Okay? So the process continues until the difference between the prediction and the correct targets is minimal. So knowing when you stop the training and what accuracy target to set is an important aspect of training neural networks, mainly because of overfitting and underfitting scenario. So buot silingon class, mag-train kita, no? May ara kita ginatawag nga ginabutang dira sa aton nga uh, tawag ni sa aton nga layer nga weights and bias vectors. Okay? And then we can adjust our kung hindi pa naton ma-hit ang accurate or ang aton nga prediction nga gusto nga desired output, we can adjust the bias. Okay? So we will learn that later on how to do it. So vectors and weights. Working with neural networks consists of doing operations with vectors. You represent the vectors as traditional or multidimensional arrays. Okay? So, sa Numpy, naton class nga lecture, I have discussed how to create a random Numpy vectors, no? Or multidimensional array. And vectors are useful in deep learning mainly because one particular operation, no? The dot product. Okay? The dot product of two vectors tell you how similar they are in terms of direction and is scaled by magnitude of the two vectors. So, ang vectors class, importante siya sa deep learning. It is because kagamit siya sang dot product. So, ang dot product, duha man lang naka-vector class, no? So, silingon, it could be 1 or 0. That would tell you, no, the direction and scale by, no? In terms of direction and scale by magnitude of two vectors. So, the main vectors inside the neural network are weights and bias vectors. Okay, so buot silingon, sa aton nga neural networks class, may ara siya nga weights and may bias. Okay? Loosely, you may want your neural network to do is to check if an input is similar to another input is already seen. So if the new input is similar to previously seen inputs, then the output will also be similar. That's how you get the result of prediction. Okay? So, linear regression model. So, you are familiar with linear regression model. It is because we have discussed this several times. So, regression is used when you need to estimate the relationship between the dependent variable and two or more dependent variables. So, we are talking about here like there is a one dependent or one dependent variable and two independent variable, no? or more independent variable. So linear regression is a method applied when you approximate the relationship between the variables is linear. So buot silingon, linear in the sense nga kung ano ang nagadepende ang aton nga independent variable, ang aton nga dependent variable sa independent variable. So, whatever their output, so nagavary na siya sa aton input. So, the method dates back to the 19th century and is most familiar regression method. So, very popular, no? A linear relationship is one where there's a direct relationship between independent variable and dependent variable. So, amo na siya nga linear sila class. There is a direct relationship between them. And if you recall, there is a method on, how to know if may relasyon ang duha ka variable or hindi. Okay? Or wala. Or good fit or bad fit, no? So by modeling the relationship between the variables are as linear, you can express the dependent variable as weighted sum of the independent variable. Okay? So both silingon, you can express again the dependent variable as the weighted sum of the independent variable. So buot silingon class, kung ano tawag ni, we can assume that the sum of the independent the dependent what is the dependent variable is the sum of the independent variable. Say for example, like uh for example, 1 plus 2 no is 3. So nagadepend ang aton nga dependent variable sa whatever nga na-generate nga weight or sum halin sa aton nga independent variable. So that's why may relasyon ina sila na. So each independent variable will be multiplied by vectors called weight. Okay? So whatever class nga may ara ang aton nga input value, gina-multiply ina naton sa weight. Okay? Ang weight class, dira na siya naton ginabutang sa say for example sa first layer. Kay ang aton class nga layer may ara siya weight and bias. Okay? And then may ginatawag siya nga activation function. Okay? You will know what is activation function later on. So, let's say for example, ang tawag ni ang A naton may value siya nga 5. Okay? Ang input naton. So, sa layer naton may ara siya nga weight nga 6. So, ang pagsuma naton sina is of course kung may 5 kita nga input, so may 6 kita nga weight. So 30 siya. Okay? Plus bias. Okay? So may plus 10 kalimbawa, so 40. Okay? So that isa pa lang ka neuron. Okay? But may multiple neurons. So, one layer is composed of multiple neurons. As well, ang aton mga input, multiple neurons man. Okay? So, after this video, no, I will also be including like a tutorial, online tutorial, in which it will explain, no, deeply, no, para maintindihan nyo gid ang concept class kay gina-show nyo gid ang step-by-step process. Okay? So, beside the weights and the independent variables, you also add another vector called bias. So, and it sets the result when all the other independent variables are equal to 0. Okay? So, buot silingon, sa layer naton, aside from input, may ara nga weight and bias sa aton nga layer. Okay? So, ginasuma naton ina siya. So, as a real-world example, how to build linear regression model. Imagine if you want to train a model to predict a price of houses based on the area and how old the house is. You decide the model, uh, you decide to model this relationship using linear regression. The following code block shows how you can write a linear regression model for the stated problem in pseudocode. So let's say for example, no, may ari kitang example dari class. I-try na to predict ang price no sang house by considering the how old no ang area niya kag how old the house is. Okay? So, we will use the pseudocode like ang weight area naton. Oh, sorry. Ang weight area naton and the area. Okay? So, ang papredict kita ka price. So, ang weights area naton. So, that means to say, ano ang ihatag ta nga value diri sa area. Okay? And ang aton nga actual gid nga area sang balay. Okay? So, therefore, like, say for example, my weight area kitang ginbutangan naton nga value diri is 5. Okay? And ang area naton is like, say for example, okay, change naton class, like 2 na lang, no? And then, ang weight area naton is 2. Okay, so ang area naton be halimbawa lang 50 square meter. So buot silingon 100 siya, no? Kung i-multiply na to 100. Okay? Plus of course ang iyang weight age. So ang ikaw nagabanta kung pila ka weight ang ibutang mo sa age niya, no? Okay? So limbawa 3 for example dere. And then, ang actual age niya is, so for example, 20. Okay? Or 10 years lang. Okay? So, 10 years plus, pilang butang naton diri? 2. Okay? So, 20. So, 20 na diri, pila to kaina? 100. So, 120 kung i-plus mo na sila. Plus ang bias niya. Whatever nga i-decide mo diri for bias, so, ikaw na ang nag-determine man sang bias value. Okay, whatever. So, let's say for example, 120 na to plus butangan ta abi halimbawa nga 30. So, 150 na ang iya nga price. 150 pila? So, 1 million 1,500,000. Okay? So, kaya tama ka barato ang bilisang area to kaina, no? So, amo na siya. Ang pag-predict naton sang price. Okay? So, in the above example, there are two weights. The weights area and the age. So, kung sa lupa class, usually kahit hindi man ni sa balay, wala ako masyado, I have no idea with about the area, no? Pero kung sa duta na, usually ang bili, like halimbawa sa mga malahalon nga subdivision, di nag-aabot na 10K. Okay? So, kung butang naton nga 10K times pila tong area naton, 50 square meter. So, dako na ni siya, no? So, most likely, dako ang bili niya. Okay? As you can see, ang sa age siya, halimbawa, the more nga ang iimo niya pag-calculate, the more nga nagatigulang siya, ang weight value niya is naga-lesser. Okay? So, buot silingon, pwede ka daya ka-create sang imo nga table man nga may ara nga ano tawag ni nga corresponding value. Like for example, kung mga 50 ang iyang age, o mga 50, mga 5 years na, so pila ang iya weight age? Pila ang medyo mahal bala or medyo barato? So ikaw pwede ka create sang table para maka-bracketing ka kag makabutang sang value. So that's why ang ginambal ta ni class nga weight, kabanta-banta ka ina siya diri. Or may ara ka gid basihan. Halimbawa, gabligya ka sang because I have no idea no class no kung tagpila sa balay na. Pero kung sa lupa iya class balaan ko nga depende sa subdivision kag most likely ang mga medyo malahalo nagadalaga na sa 10K or up. Okay? So, ang time sa area niya. Okay? So, diri nagasulod class nga pwede ikaw kakalculate sang presyo sang balay. Depende sa ano kalapadon, depende sa kung ano naka gulang ang balay. Okay? So, the higher the age, pwede mo da makaobra ka computation nga mas nagabarato. Okay? So, amo na siya ang example class sang pag-ubra naton sang prediction using sang linear regression. So, again, may ara sa aton layer, may ara kita nga weight, may ara kita nga bias. So, whatever ang input naton dira nga gina-consider, tagaan naton siya sang corresponding weight. Ang weight, kita ang pwede magbanta sang weight. Or, it depends on the sa aton nga ano tawag ni nga algo nga ginagamit kag kita ginaga-check kung pila ang weight nga ibutang naton. Okay? So in the above example, there are two weights, and the training process consists of adjusting the weight and the bias, no? So that's why again, ga-adjust kita sa weight and bias. Kaya ang weight class, may factor ina siya, no? Hindi na siya palagpat usually, no? Kung in real world, may formula ini siya. Kung depende, no? Kung bartuhon ng area, or gulang ng balay, or ano. So depende kung kita man nagabanta kung anong i-value naton. Okay? So to accomplish that, you'll need to compute the production error and update the weights accordingly. Okay? So makapredict ka, halimbawa, you are trying to calculate like maka-come up ka sang 1.5 million abi nga bilis ang balay, and then basically diri ka ga-adjust, no? Ari static ni siya eh. Kung nabalaan ng area, hindi mo ma-adjust. Kung pila age niya, hindi ma-adjust. Diri kita, pwede kita ka-adjust sa bili, ho. Okay? Kung especially kung may ginagapa-calculate sa aton, so limbawa, hindi, abi kita. Okay? So, we'll just adjust this one and adjust this one. So, makakalculate kita sa price nga ginatry nato na gina-project. Okay? So, magambal naman siya, abi nga gusto ko mas barato nga balay. Okay? So, basically, ang factors nga mag-affect sina is ang bilis sang per square meter. Okay? And, syempre, kung ano ka tigulang ng balay. Okay? So, those are the thing. So, these are the basic of how the neural networks or how neural network mechanism works. And now, it's time to see how we apply this using in Python. Okay, so wrap up. So, may ara kita ginatawag again class nga input. May ara kita layers. So, ang layer depende, no? Magatawag na siya hidden layers. Depende, no? Kung pila na ka-layer dira. Okay? The more nga damo ang layer, the more nga more precise ang aton prediction. And then may output kita gina-expect. Okay? And then, kada layer class, may mathematical formula or function nga nagasolve, okay, sang aton nga mga input. Okay? So, kag kada layer, may ara nga weight and bias nga pwede naton tawag ni i-adjust, no, para at least makuha naton ang insaktong output that we're trying to predict. Okay? And then, now let's proceed, no, on how we're going to use the neural network applied in Python. Okay? So, the first step in building a neural network is generating an output from input data. So, you'll do that by creating a weighted sum of the variables. So, the first thing you'll need to do is to represent input in Python and Numpy. So, if you are using Python, so Numpy ang aton nga because we're talking about vectors, no? But basically, we will be learning like, say for example, image classification and other application that probably lain ang input na ginagamit. Okay? But again, we have for this particular example, we are going to use the vectors. Okay? So wrapping inputs in neural network with Numpy. So you'll use Numpy to represent the vectors of the neural network as arrays. Okay? But before you use Numpy, it's a good idea to play with vectors with pure Python to better understand what's going on. So in this first example, you have input vector that the other two weights vector, no? So kung baga may are input vector and there are two weights vector. Okay? The goal is to find which weights is more similar to the input, taking into account the direction and magnitude. This is how the vectors look if you plot them. So, Ambalya class, the the best way to represent is using NumPy, but it is better to represent them in Python. So in this particular example, try naton i-predict no nga which weight is more nga lapit sa input. So considering this Cartesian plane no, x and y axis, amo na yung input no. And then this is the weight 1 and weight 2. So kung visual lang paglantaw naton class, so basically um amo ni ang pinaka ano no, pinaka similar, ang pinakalapit sa input because of the direction and the magnitude. So hindi man pwede amo ni kay dichon mo ni class dito ni direction wala na siya kada ano kay sa magnitude amo man. So wait to using sang visual. So three vectors in a Cartesian coordinate plane. So the weight to is more similar to the input vector since it's pointing to the same direction and magnitude is also similar. So, how do you figure out which vector is similar using Python? Paano ko no? First, you define the three vectors, one of the input and the other two of the weights. No? When you compute how similar input vector and weights 1 are, to do that, you'll apply the dot product. Yeah? Since all the vectors are two-dimensional vectors, these are the steps to do that. So first, we're going to multiply the first index of input vector by the first index of weight 1. Okay? So buot silingon, we will calculate this value, no? Kumbaga, i-compare naton ang aton nga first, sa ano kita klasa sa array kita. So, ang value nga ni, okay, this is amo na yung first index is 0, no? Amo na siya ang value. So, ang input vector mo nga index 0, i-multiply mo man sa dere. Okay? So again, the first index of input vector by the first index of the weight. So input vector nga ari kay multiply mo siya diri. Okay? So and then multiply the second index of input vector nga ari by the second index of weight 2. Okay? So ang ari naman, ang next naman is ang ari naman ang multiply ang iyang second index no ngari by the second index of the weight 2. So amo ni siya ang i-multiplyan. So we are going to run this. So we have this input. So first again how to do that, say first index no pauntang input vector value or ang i-index value i-multiply naton sa weight 1 nga. So ang answer niya amo ni. So karon ang second index na naman i-multiply naton sa vector, okay, sa input vector naton. Okay, input vector nga ang value niya is ano kay tawag ni? Ang index 2. So i-multiply naton siya sa weight 2. Weight 1, no? Weight 1 nga index value niya is 1. So, but silingon, ang ari, i-multiply na itong diri. Ang ari pagid, i-multiply pagid na itong diri. Okay? So, therefore, ang aton nga ano, kay ari masiro na nimo. So, amo niya ang aton nga sabat. So, 2.1672. Okay? And then, um, using the dot product, okay, dot product 1, so i-plus nato na siya. First indexes plus second index value. Okay? So, amo na siya class ang how are we going to do that, no? So, kung i-multiply na to na siya, actually, no, ang ano gayud tag ni, ang ang value naman naton, okay, ang next na naman is nga obraw naton is for input vector naman nga i-compare naton sa weight 2. So, amo naman ni kuhaon naton, tapos amo naman ni, tapos amo naman ni. Okay? So, ira nato ni. So, the result of the dot product is 2.167. Now that you know how to compute the dot product, it's time to use np dot dot, no, function from Numpy. So, how are you going to do that? So, hindi mo kinanglan isa-isa ho, no? Just you use the dot np dot nga function. Like, dot product is equal to np dot, then vector, and weight. Okay? So, let's say, try natin ang 2, no? Okay, amo ni ang results ang 2. Kung i-multiply natin siya sa 2. Okay, so, that's why, kung lang taon natin class, ang values ang 1, 2 point something. Kung values ang 2, 4 point something. So, diin ang mas higher, this is the higher. Okay, that's why, mas similar siya sa weight 2. Okay? So, ara. So, amo ni siya ang next gali na nauna na kita. Okay? Again, instead of specifying nga isa-isa naton kay karon kung damo na diri class ang aton vector, damo naton nga weights, ayawan kita na kay isa-isa. So, we'll just use the np dot. And then, we will input the value or ano na siya gani ang tawag sa aton nga ini? This is our input and this is our weight. Okay? Kulang na lang na di bias class, no? Kag makatawag ni kita nga neural network siya. Okay? So, amo na siya class ang basics ang kung baga paano mo gamiton ang o paano mo tansyaon ang weight, no? Okay. So, input dot does the same thing you did before, but now you just need to specify the two arrays as argument, no? So, amo na siya. And this time, the result is this one. So, as different way of thinking about the dot product, you can treat the similarity between vectors coordinate as an on-off switch. If the multiplication result is 0, then you will say that the coordinates are not similar. The result is something other than 0, then you will say that they are similar. So, buot silingon class, pwede ka man nakahambal nga if this is equivalent to 0, okay, so they have no relationship. And if it is other than 0, like the rate 4 siya, no? And the rate 2 siya. So, although hindi siya ang pinakalapit, at least may relasyon siya gyapon kay 2 point something siya. Amo man sinino, amo ni yung pinakalapit. So, wala lang siya nag-0. So, kung nag-0 ini siya, either diri kag diri, so both silingon they have no relationship, no? So, but again, the best production is this one. Okay, the weight 2. So, this way, you can view the dot product as a loose measurement of similarity between vectors. Every time the multiplication result is 0, the final dot product will have a lower result. So, getting back the vectors to example, since the dot product input vector and weight 2 is 4.1259 and 4.1259 is greater than 2.1672, it means that input vector is similar to weight 2. So, tama ang aton assumption, no? Or tama gid ang aton panulukan, no? Visually. You'll use the same mechanism in your neural network. Again, pwede ikaw naka-class it's like, saying nga, pagkakita mo class nga almost similar sila, hatagan mo siya dako nga weight. Okay? Kung hindi sila similar, butangan mo gamay nga weight. No? It's like also sa aton pagkuha sang price. No? So, kung tigulang na siya, or dugay na ang balay, medyo barato na. Tagaan mo siya mas presyo nga barato. So, kung dako man ang area, kag medyo mahal man ang location, medyo mahalon mo man or tagaan mo value, mahal ang weight. Okay? So, I hope you understand. Okay, so in this lesson, you'll train a model to make prediction that have only two possible outcomes, no? So, the output can be either be 0 or 1. This is a classification problem, a subset of supervised learning problem in which you have data set with the result and known targets. So these are the inputs and the output of the data set. So I will be giving you a activity or assignment, which this is the input vector, and we have this target no for this particular input vector. Ang target natin is 1, and this for particular input vector target natin is 0. So kamo mabanta class sang ano ang weight value nga inyo nga i-butang. Okay, so that will be your activity, and I will be giving you that one. So the target is a variable you want to predict. In this example, you're dealing with a dataset consists of numbers. So it isn't common in the real product scenario. Usually, when there is a need for deep learning model, the data is presented in files such as image or text. Okay? Okay, so making your first prediction. So since this is your very first time in a neural network, you'll keep things straightforward and build a network with only two layers. So far, you've seen that in the only two operations used inside the neural network were the dot product and the sum, no? But are linear operations. So, ang gingamit ito kay ina class sa pag-predict sang like price and the input the input vector and the weight, no? Weight 1 and 2, linear to siya ang operation na ginagamit. So if you add more layers but keep using only linear operation, then adding more layers would have no effect because each layer will always have same correlation with the input of the previous layer. This implies that if a network with multiple layers, there would always be a network with fewer layers that predicts the same result. So kung nagagamit ka kuno class sang same man lang nga linear operation all throughout layer 1 and 2, same ang gyapon nga output ang expect nimo. So kumbaga, kaya mo man ang input, so probably same lang man gyapon nga may kinalain, pero syempre linear man gyapon ang operation. So there is still a relationship sa kung anong input kag kung ano ang output ang sa next nga layers. Kumbaga, ang mathematical operation mo daw mo siya gyapon kag we are expecting same result. Okay? So, what you want to find an operation that makes middle layers sometimes correlate with input and sometimes not accurate, no? Or not correlate. So, may lain kita nga gamiton nga function para may twist. Kay kung amo lang gyapon, wala twist. Okay? You can achieve this behavior by using nonlinear function. So this nonlinear function called activation function, there are many types of activation function. So ginahambal ko ni kay na class nga from the first layer, although may ara kada nga input, may weight, kag may ara ka bias, may ara ka ginatawag class nga activation function. So there are many types of activation function, no? For example, is a function that converts no Ario rectified linear unit, is a function that converts all negative number to 0. Okay, so this means that the network can turn off a weight if negative adding nonlinearity. So, pwede ka kung kagamit sa rectified linear unit to make a computation nga all negative number or value i-convert nimo sa may 0. Okay? So, buot silingon kung less than 0 siya kag mga negative value siya, automatically 0 siya. Okay? Again, ginalantaw man lang naton nga using that that product, there is only two no value like 0 and 1. Okay? So, pareho man ni siya, no? So, kung nabilong siya sa negative, 0 na siya automatically. Okay? So, the network you're building will use sigmoid activation function. You'll use it at the last layer or layer 2. The only possible output in the dataset is 1 or 0, and the sigmoid function limits the output to range 0 and 1, or between 0 and 1. This is the formula to express the sigmoid function. So, say for example, kainano class, you have a first layer using linear regression. May ara ka nga value, let's say for example, 2 point something, no? Sa prediction to bala sang weight 1 and weight 2. So, ang weight 2 may value sa nga 4 point something. Amo na to siya ya ang value sang imong prediction sa layer 2, sa layer 1. So now, may ara kita ginagamit nga sigmoid activation function nga ara sa layer 2. Sa layer 2 naman niya, ang output niya is 0 or 1 lang. Okay, so buot silingon, in this particular example, gusto ta nga magkakuha sang output nga 0 and 1. Okay? Or for the whole, parang nga concrete gid naton class. Like, say for example, kaya try naton nga predict nga ang input value naton sinugid bala sa ila. Weight 1 or weight 2. Para ma-sure gid naton 0 and 1 ang aton nga pilion. Okay? Kay again, kung ibalikan naton class, say layer 1, ang gingamit naton is linear regression. So, may value na kita nga 2 point something and ang weight 1 is 2 point something kung gamitan naton, no. Ang weight 2 naton is 4 point something. So, hindi na siya ka-concrete, no? Wala pa ni siya sang kumbaga finality ang layer 1. Maagi pa siya sa layer 2. So, sa layer 2, gamiton naton sang sigmoid activation function para nga may finality na kung ano gid bala ang mas eksakto nga prediction sa input value, ang mas similar. That's why, gamitan naton sang 0 and 1 nga value or sigmoid activation function, which result sa 0 or 1. No? Dili siya ma-output. 0 and 1 lang. Okay? So, amo na siya class ang sigmoid function formula nga gamito na ito sa layer 2. So, the E here is a mathematical constant called Euler's number, no? You can use np.xp, no, to calculate this one. So, hindi mo na kinanglan magpapalibog. Amo lang gamiton mo. Probability function give you the probability of occurrence of possible outcomes of an event. The only two possible output of the data set are 0 and 1. And the Bernoulli distribution is a distribution that has two possible outcomes as well. So, pareho man sila ni sigmoid activation function. No? The sigmoid function is good choice if your problem follows the Bernoulli distribution. So that That's why you're using it in the last layer of your network or neural network. So since the function limits the output to the range 0 to 1, you'll use it to predict probabilities. No? If the output is greater than zero point 0.5, then you'll say that the prediction is 1. And if it is below zero point 0.5, then you'll say that the prediction is 0. Then his follows, or this is the flow no, of the computation inside the networks you're building. So, it is like having like input, dayon ang weights naton. Then, pag yun naton siya sa dot product. Okay? So, sumahon naton. Parito ginobra to sa previous example. And then, butangan naton siya sang bias. Then, may result na siya. Then, maagi na siya sa, result, may layer result 1 na kita. Like, for example, 2 point something and 4 point something. Dayon, maagi na sa next layer. Agyan sa ni Sigmoid activation function, no? And then may prediction na kita. Okay? So, amo na siya class ang aton nga example. Okay. So for example, the yellow hexagon represent the functions and the blue rectangle represent the intermediate result. Now, it's time to turn all this knowledge into code. No? You'll need to wrap the vectors in Numpy array, and this code is applies to a function represented in image below. Okay. So, amo ni siya ang aton nga value. No? So, it's like having this weight, no? Makalculate kita. Halimbawa, we have this value again for the input vector na may ara sa nga value nga amo ni, no? 1.66 to 1.56. Okay? Or, yes, amo na siya aton nga array. And weight 1, okay, amo na aton nga. Then, ang bias ang ginhatag naton. And then, pag yun, amo ni ang formula, no? And then, pag yun naton sa sigmoid function, okay? And then, make difference, no? So, this is for the layer nato, no? Layer 1. Okay, hatagan nato siya sa formula. Layer 1, input dot dot. So, hambal naton kaina sa using input dot. Butangan lang naton dayon sa sang vector, input vector kag ang weights plus bias. So, ang weights naton na ginamin diri is ang amo ni, no? Amo ni aton nga weight diri. Okay? And then, of course, ang layer naton, layer 2 naton, ang sigmoid naton, tawagon niya lang na nga aton. Okay? And then, return layer 2. And now we make a prediction. We make prediction, input vector, weight 1, bias. And then we'll run. And of course, we have this result. Ang result naton class is 0.7. Po 0.7985731. So this result would say that ano gani siya? 1 ni siya ang pag-calculate, no? Because again, sa sigmoid function, there is only 0 and 1 gin-interpret niya. So, may ara kita nga value nga if higher point taas sa 0.5, 1 siya. Kung lower sa 0.5, 0 siya. So now we have 0.7, so 1 siya. Okay? So the raw prediction result that 0.79, which is higher to 0.5, so the output is 1. The network made correct prediction. Now try another prediction input like amo ni ang input halimbawa naton. Then the correct result of this input is 0. Okay? You only need to change the input vector variable since all the other parameters remain the same. Okay? So, amo ni ang gin-change naton. So, pag-change naton, amo ni na. Okay. So, this time, the network made a wrong prediction. Nga aman ko no. The result should be less than 0.5. Okay. Why? Since the target of this input is 0. Okay? But the raw result was 0.87. So it made a wrong guess. But how bad was the mistake? Okay? So, next step, you're going to assess that one. So, buong silingon sini class, kay try na to, no? The correct result is 0. You'll need to change the input vector since all the parameters remains the same, no? Ang balik ina, the network with the correct prediction. Now, try another vector, input vector, this one. The correct result for this input is 0. So, ginatry naton nga, tag ni, i-predict ang value sa input vector using this one, no? So, kung amo na ang pag-solve naton class, then may ara kita problema sa aton nga uh, formula or may ara kita problema sa aton nga prediction. So try naton abi na nga dili naton siya ibutang, no? Kung ano man ang iya result. So amo gid siya class. Oh, control MC. Control MC. Ano ba? God, control. Ayun na. So, buot silingon, hindi kita ya dapat mag-change sa input vector, no? Dapat somehow, ma-change kita ya sa aton nga, ano, nga weight. Okay, kung gusto tayo i-predict na 0. Okay? However, um, may ara kita next topic, no? Kung paano naton mabalaan nga how ano kadako ang mali, no? How bad, no? It made a wrong guess. But how bad was the mistake? Okay, amo na ang next naton nga topic. Okay? So, for now, I think we'll end our discussion here. Our lesson, no, para at least in the information overload, and I will be uploading an example para at least matry ninyo before we proceed to the next topic. So I hope you get something or you understand some topic here. I will give you this notebook, and again you may download and you may produce your own. Do not try your code here because this particular notebook I will be using again. Sumpunan ko lang ni class, so hindi nyo pag-intrahan para nga ang iba nga section, okay, ma-correct ang output ni rin, no? Kaya hindi nga sa nyo ko modify dayon mali ang pag-calculate o ang result. Okay, so I think that's all for this session. So we'll proceed or we'll proceed with the other topic for neural network after this session. Okay, thank you everyone.